The first stage is to set up the tripod over the point from which the angles are measured. In this case, the point or station is marked by a nail which has been driven into the top of a wooden peg. This instrument station will be designated Station A. In this case, there will be 3 other stations which will be designated Stations X, Y, and Z. We put ranging rods next to the stations to help locate them when we are looking through the theodolite. However, the exact station is the nail in the top of the peg. Leave the theodolite in its box for the moment. Undo the tripod and extend its legs, but not completely. Place the tripod approximately over Station A. It's important to set it at a convenient height for you to work at and to make sure that the head is reasonably level by eye. Suspend a plumb bob from the tripod. Some tripods have a hook, or you can use a chain arrow across the top. Note the position of the plumb bob and then move the feet of the tripod to bring the plumb bob within 10 millimeters of the nail. All 3 feet must be moved by the same amount and in the same direction. This will keep the head reasonably level. While you hold onto the plumb bob, push the feet of the tripod into the ground. Be careful if the ground is hard. If one of the feet won't go in as far as the others, don't worry. Now suspend the plumb bob once more. Adjust the length of each leg to bring the plumb bob back to within 10 millimeters of the nail. At the end of this procedure, the tripod head should still be reasonably level. Now make sure that the wing nuts on the tripod are all tight and check the screws on the adjustable legs. This entire procedure is known as rough centering. The tripod now provides a solid and stable platform for the theodolite. Before you take the theodolite out of its box, have a good look to see how it fits in. Lots of students waste time after they've finished measurements because they can't work out how to put it back. When you lift the theodolite out, hold the standards. Never lift it by the telescope. Undo the upper plate and screw the theodolite onto the tripod head, keeping a good hold of it with your other hand. Don't forget to close the box in case it starts raining. The next step is to level the instrument, and this is done using the 3 foot screws in conjunction with the bubble which is on the upper plate. Bring the bubble to the middle of its run by rotating the 2 foot screws in opposite directions. As a guide, the bubble moves in the same direction as the left-hand thumb moves on the foot screw. Next, turn the bubble tube 90 degrees clockwise and bring the bubble to the middle of its run using the 3rd foot screw. Return the bubble tube to its first position and check to make sure the bubble is still in the middle of its run. If it isn't, put it in the middle again using the first 2 foot screws. Return the bubble tube to its second position and again check it. If the bubble isn't in the middle of its run, use the 3rd foot screw to adjust it. This procedure is repeated until the bubble is in the middle of its run in both positions. Now rotate the bubble tube until it is 180 degrees opposite the first position. Note where the bubble is. Here it happens to be 2 divisions out to the right. Don't touch the foot screws. Turn the bubble tube so it is opposite to the second position. Again, note where the bubble is. 2 divisions out to the right. This means the bubble tube is slightly out of adjustment, which is quite a common condition. In positions 1 and 2, adjust the bubble so that it is 1 division out to the right. This is known as taking out half the error. Check it in both positions. Now check it in positions 3 and 4, and it should be 1 division to the right. Providing the bubble occupies the same position anywhere in a 360-degree rotation, the theodolite is level. Once you know the position of the bubble on your theodolite, you can set it up straight away without going through this procedure. The next stage is to center the instrument exactly over the top of the nail which forms the station. Looking through the optical plummet, you can see an index mark which must go over the nail. Undo the centering clamp and slide the instrument until the index mark is exactly over the nail. Then tighten the clamp. Unfortunately, the act of centering can upset the leveling, so you must check it once more. However, the full procedure isn't necessary, since you now know where the bubble should be for the instrument to be level. Once you've rechecked the leveling, check the centering again, since the re-leveling can upset the centering. However, you usually only need to do this once. You've now finished setting up the theodolite above station A, and it is ready to use for measuring horizontal angles. First, you select one of the stations as a reference station. This point should, if possible, be the most clearly visible and the most distant of the stations to be sighted. All the horizontal angles will be referred to this point. In this case, station X will be chosen as the reference object. Conventionally, the observation procedure for horizontal angles begins with the instrument on face left. Remember, the face of the theodolite is the side containing the vertical circle. When you look through the telescope and the vertical circle is on your left, the instrument is said to be in the face left position. Horizontal angles are measured using the horizontal circle on the theodolite, which consists of 2 concentrically mounted plates, the upper plate and the lower plate. In simple terms, you can think of the lower plate as a circular plate of glass which is graduated from 0 to 360 degrees around its edge, while the upper plate is another glass circle which has a single index line marked on it running from its center to its edge. You can clamp or unclamp each plate and then turn it slowly with its slow motion screw, which is also known as its tangent screw. You read the horizontal circle using the optical reading telescope which is fitted on the side of the instrument. When the 2 plates are clamped together, the telescope cannot be rotated in the horizontal plane. When the upper plate is freed and the lower plate clamped, you can rotate the telescope in the horizontal plane and the horizontal circle readings change. That is, the index mark on the upper plate moves over the lower plate. When the upper plate is clamped and the lower plate is free, the telescope can again be rotated, but now the horizontal circle reading does not change, since the index line on the upper plate is clamped to the lower plate and both turn together. Ideally, the initial reading on the theodolite, when pointing to the reference object on face left, should be slightly greater than 0 degrees. This simplifies subsequent calculations. This is how we measure horizontal angles. In the face left position, open the mirror and free both plates. Set the horizontal circle to give a reading between 0 and 1 degree. Clamp the upper plate and you will retain the reading. Point the telescope at the ranging rod using the sights on top. Clamp the lower plate.